Okay, I think we're live. So I just wanted to, I've been doing these little streams over the last few days about closures in C and nested functions, and the fact is closures are probably coming to C soon, and in the meantime we have nested functions with a better implementation in GCC. So to avoid the stack-based trampoline problem. Um, and I was doing a whole bunch of stuff with HTTP type interactions. But yesterday I spent a little time in the evening just wrapping up some other types of functions. So I just wanted to show you the kinds of things that are possible. I guess we'll make this even bigger. Um, so what if you had a file write function that takes a function that receives the file. The file write function takes a mode to open the file with, and then like a printf type template for the file name. So I often find I'm struggling with file names in C. It's one of the places that in something like Node.js where you make a file and you do something like in Node.js you'd probably do path.join, wouldn't you? So you might have dir name, and then you've got some dir and then some file. And doing this in C would require allocation and be a little bit tedious, maybe. But the nearest thing we'd have to this would be something like printf, I think. So having this printf thing is like the path.join, and then here's two things. So I'm wrapping up the creation of the file name and the temporary allocation of the storage. I don't need that string storage after I've created the file name and opened the file. I don't need it. It's really ephemeral storage. So making that, copying these things into it with printf, that seems pretty reasonable. And so let's just go and look at the implementation, I guess. That's terrible. We'll just go there. Can't remember how to go, how to visit the thing. Do you do that? No, you don't do that. We'll just search for it. So here's the implementation. You can see it takes this writer and it just opens the file, does the printf with the file name template, and then it just opens the file and calls the writer function. That seems like a pretty useful thing to me. So I think that one of the things that we're going to get maybe in standard libraries is these more function-based calls. So then there was another example. I wrote this one first. This was kind of obvious. But then there was another example to me. In the same code, I was doing this sort of thing. I was making a so this location string is actually starts off as a slice type. So it's just basically to a pointer and a len into a bigger buffer. So that's the response header buffer, of course. But to get it into JSON, I'm going to have to copy it out as a string. Okay, so then I thought, well, that's my own library. I've got my own slice library. What if I made a slice copy F? So slice copy normally takes a string buffer. And so what you normally do is to take the length of the slice, allocate a string buffer, and then call slice copy to copy the slice into the newly allocated string buffer, and then do with the string buffer whatever you want. And again, one of the reasons to use slices is to cut down on the copying. But in the end, you've got to do a copy, haven't you? You've got to copy. You're gonna copy it onto the socket in a network programming. But you might be copying it into a file or copying it into SQLite, which is just another form of socket, I guess. But there we go. Actually, it's not, is it? It's a file. Anyway, whatever. You get my point. The copy is kind of the last thing you'll do, maybe, if you've got a slice and you can do comparison on the slice and all of those things. But eventually you're going to want to copy the slice, probably. So what if we had a slice copy f, which takes the function to handle the resulting copy? So this function copied is called with the resulting copied string. So the allocation, all of the memory for that copied string, all happens outside of the function. So I mean, there's a function call here. I guess it could be inlined. I guess. I don't know how good compilers are going to be at deconstructing these sorts of nested function callback, closure type scenarios. Maybe they'll be terrible at it, in which case we're paying the price for lots of function calls. But it seems like they'd be able to inline it. Anyway, you get the point. It makes that much easier. Again, though, we can see that it would be better to have textually inline, lexically inline control flow. So we'd be able to say, I guess, slice copy f. Both. The other interesting thing is that both of these are being forced into function first, which perhaps is not so good from a readability point of view. But let's look at this. If we could I can't remember what the syntax for lambdas is. So what I'm trying to say is that I don't want to forget this. Oh, let's just go make a new one. So it's probably a return value. So slice copy f, comma location. So that's the slice, and then we'd have so will we have like JSON writer, and I think these are autos as well. So I don't think we need anything about the thing. Maybe we do. Let's say we do, just for funsies. So this is JSON file, and I don't know. Does it need that? I don't think it does need that. I think it's the brackets that make this. So why is that not indented? Anyway, I'm gonna just fake indent it for now. And after this, we have this stuff. So yeah, there we go. Is that right? Or would we have like file? Yeah, we'd have file right. Oh gosh, that's quite a mess, isn't it? It's quite hard to imagine. So JSON writer is taking a function, right? So it's taking a JSON writer is taking a function that is going to call slice copy f. Yeah. So we need this indented. Yeah, this needs to be indented. Yeah. And then this stuff. And hideous. Obviously, the kind of rules don't work. The indentation rules don't work. But there you go. So this would be the lambda style. You've got a lambda that, so this is declaring what is captured, so there's nothing captured, and then we're doing all of this, and then we're calling fwrite on the JSON file. So I guess you could say the JSON file is captured. I'm not sure what would work there, but I mean that seems reasonable. Anyway, the point is, you know, all of this will be possible. These are two really obvious ways, I think, of let's just kill it and open it again. It's called acme.c. And here we are. We're back to the thing. So that lambda control flow might be a better way of expressing what I'm expressing here. But really what fascinates me is that, you know, these are like, this is my first few days of thinking about, like these things just haven't been available. Like there's no point using nested functions because of the terrible implementation. But now these things are available to us. So we've got nested functions. It works. It's sensible. And this is and closures are coming. These are the very first things that we start to do with it. These are kind of like, yeah, okay, we could have libraries that passed in a function to do the completion and manage the resource allocation. Oh, interesting. It's not just defer that we're getting. It's, all of this new stuff that could make libraries and writing C code so much safer and simpler. And this is just the first sort of 5 minutes of playing with this. What about, MapReduce type patterns? What other patterns can we invent around wrapping up resource allocation and using closures to do it? So anyway, yeah, I think that is super interesting, and I did want to take just a few days before Christmas. Happy Christmas. If you celebrate, today is Christmas Eve, so have a good one if you celebrate. And I just wanted to take those few days just to talk about this, put this out there. Hopefully somebody somewhere might get some value out of it. But if not, and this revolution in C programming happens, don't say I didn't tell you. Okay. Thanks very much for watching, if you do, and see you all again in the new year.